Let's do another example. Let's solve e to the 2x minus e to the x equals 2. Now the first thing that we did in the previous example is we tried to rewrite this as either one exponential equals a number or one exponential equals another exponential. And if we try to do that here, then I don't really see how I could do that. If I add e to the x on both sides, I get e to the 2x equals e to the x plus 2. And now I don't have a number to something involving x equals just a number to another thing involving x. Or in other words, there's this extra plus 2 here, which actually makes things complicated. If you tried to mimic the steps from the previous problem and took logs of both sides, ln of e to the 2x equals ln of e to the x plus 2, it's correct to write, but I'm not sure how much it helps, because although this 2x can drop down, we cannot drop any exponents down in the expression on the right-hand side. So we're going to need a different idea, and that different idea will be something that you are familiar with up until now. It is this idea of factoring. Let's make the problem a little bit easier for a moment. What if I asked you to solve w squared minus w equals 2? Well, this is a quadratic equation in w. If I move this minus 2 to the left-hand side, then I can factor as w minus 2 times w plus 1. And so w equals 2, or w equals minus 1. Now, it turns out that these two equations are actually very related. In order to show you how they're related, let me define w equals e to the x. Well, if w is e to the x, then what would w squared be? It would be e to the x squared, which is e to the 2x. And here we're just using properties of exponentials. So w squared is e to the 2x, and w is e to the x. So I can put w here and w squared here. And the result would be that w squared minus w equals 2. Now, we know how to solve this new equation for w. In fact, we've already done it. We have w squared minus w equals 2. We can go ahead and move the 2, factor, and we get that w is either 2 or minus 1. So that tells you what w is, but the original problem was phrased in terms of x. So what we'll do is we'll go ahead and use the definition for w, the fact that w is e to the x, in order to solve for x. So w, that's the same thing as e to the x. So e to the x could be 2, or e to the x could be minus 1. So what we got here are two equations. E to the x equals 2 and e to the x equals minus 1. And both of these are relatively easy to solve. If I take the natural logarithm of both sides, maybe I'll do that in a new line so I don't crowd everything. Then the x drops down, ln of e is 1, and I get x is ln 2. And now in the second equation, we have e to the x is minus 1. But we know that any base raised to any power will always be bigger than 0. So e to anything could never be negative, so this will have no solutions. And so the only solution is going to be this ln2. So sometimes you're going to get one piece of the solution, if you will, that doesn't give you any additional solutions. So to recap here, to solve e to the 2x minus e to the x equals 2, we set w equal to e to the x. We rewrote the equation in terms of w. And then we solved the equation with w. Then we set w equal e to the x, or perhaps it's better to say we use the fact that w equals e to the x to solve for x.